Now let's consider the same circuit, and we want to determine our Thevenin equivalent using source transformations. What we recognize is we can transform our Thevenin equivalent on our left-hand side, i.e. our 125 volt source and our 50 ohm resistor, into a Norton equivalent. This will allow us to sum our current sources in parallel configuration, as well as determining our equivalent resistance. In doing such, our I sub P value would be equal to our Vs per Rs values of our original Thevenin equivalent. That is, I sub P would be equal to 125 volts per 50 ohms, which gives us 2.5 amps, and Rp would be equal to Rs, which was our Thevenin resistance taken as 50 ohms. Now that we have that, we have two current sources in a parallel configuration, such that Ip plus 2 amps would yield a net 0.5 amp upward. And then we can determine our equivalent resistance of our resistors in a parallel configuration. That is, we'd have 50 ohms times 200 ohms over the quantity 50 plus 200 ohms, which gives us an equivalent or Thevenin resistance of 40 ohms. Therefore, we would have our open circuit voltage expressed as ISC, which was found as 0.5 amps, times our Thevenin resistance of 40 ohms, which gives us 20 volts. And we recognize that we still have the same Thevenin resistance, short circuit current, and open circuit voltage values as we did from our two other methods.